GenAI in general. I used to say it was at least as important as open source and probably as big as electricity. I now say it's somewhere between electricity and steam engines in terms of how it will transform the world. I like the spirit of exploration, experimentation that starts with, let's figure out what we do with it. So let's actually use it. As an example, 97, 98% of developers are using some form of AI, at least on the side. What will come with it? It will be transparency requirements, risk management, risk reduction requirements. And it is good that it works that way, at least in the system. People shouldn't be experimenting with the nuclear arsenal, using GenAI on the nuclear arsenal, but commercial grade applications, I'm delighted.
Hello, I'm Dhillon, your host, and today on your AI Injection, we're joined by Matt Van Itallie, founder and CEO of Sema. With a career dedicated to developing code assessment tools and pioneering AI-generated code management, Matt's created some impactful tools like the GenAI Code Monitor. Matt comes to us with a bachelor's degree from Swarthmore College and a JD from Harvard Law. Matt, thanks so much for coming on the show. I'm looking forward to how some of your innovations have helped shape development practices for software developers and maybe diligence applications and potential conflicts with software licenses. Thanks so much for coming on the show. Maybe start us off by telling us what inspired the creation of Sema and what major gap it fills in the software development lifecycle.
Absolutely. And first, Deep, thank you so much for having me on. I'm really looking forward to the conversation. Sema got started more than 7 years ago with the goal of making software engineering broadly understandable to non-tech audiences while also being precise and accurate for technical audiences, bridging the gap between tech and non-tech, as we say. The original use case was mine, sitting in executive team meetings and wishing I had a clearer understanding of what the engineering teams were up to and what strategic investments were necessary to help make the product as strong as it could be. I kept looking at we use Salesforce at the organizations I worked with, but any CRM, it was so clear that anybody, whether or not they were a salesperson, could understand the broad direction of the state of sales and the health of the sales team. And I thought that code should have that too. It's a hard problem because there's so many different flavors that make it a lot harder to understand code versus sales, but a noble one, because if you get coding right, you can make code understandable to non-technical audiences. You will unleash so much more innovation and so much more organizational success.
I mean, it's an interesting concept. Developers certainly understand the sort of limits of talking about the code. At some point where you're just like, I don't want to have this conversation anymore. I just want to go look at the code and see what's going on. And I think it's interesting to project that up and out of the team itself. I imagine it's quite challenging, though, because a lot of times there's some really geeky, nerdy things that one has to do as a software engineer, refactoring, or you're in the nuggets of an algorithm or something. And I've always seen that it's more like social resistance to trying to understand what's in the code than it is an inability to understand what's in the code by non-technical audiences. Are you seeing something similar to that?
Yeah, it's a great question. Before I did the work that I do now, I was a school district administrator looking at data to try to improve student learning and teaching. And one of my favorite quotes from the education days comes from Kierkegaard, a philosopher in the 1800s, that if you want to teach someone, you must first learn what they know and what they don't know. And so my broader takeaway from that, which I try pretty hard to live, and certainly Sema as our product strategy tries to live, is we should be bending over backwards to make something understandable to the audience. Really go out of our way to put things in terms that the audience can understand. If you do that, you make it more likely that they get what they need out of the conversation and you get what you need out of the conversation. A tiny example from one of our products. You can think of, we have two products. The first one is a code scan, kind of like a home inspection. It looks at the roof, plumbing, and electricity all at once, and typically around the buying and selling of a house. Our code scan product looks at different areas like code quality, security, cyber, like GenAI, which we'll talk about. So comprehensive and frequently happens during technical due diligence or prepping for diligence.
Like dependent libraries and the licenses that they come with.
Exactly. Open source license risk, open source security risk, open source version risk, all of those factors. Exactly. So let's just take security warnings for a second. When we look at security warnings, one of the documents we produce is a summary. In that summary, we give a color coding: green, yellow, orange, red. Everybody who's ever seen a traffic light knows that green is better and red is more risky. And what we do is we take each code base, we compare it to a relevant comparison set, such as a software organization with a similar amount of code, similar number of developers, similar age of the code base, and we just count the security warnings. We don't talk about any specific ones. We're just doing a count. And if the company, if that code base is green, that means relative to the other cohorts, they're in the top 25%. Yellow second, orange third, red fourth. From what we've learned from our customers, that's usually enough to start the conversation. Because if you're going to a board of directors meeting or talking with a non-technical CEO, they don't need to know how many cross-site scripting warnings they are. They need to know, roughly speaking, how are we doing on security? And so to start with that kind of empathy, we found a very positive reaction, overcoming some of the fear and the hesitation for non-technical audiences to understand it. And then, of course, they can ask follow-up questions, or they know that they can ask someone who can really understand the detail to get to the bottom of it. I see that we're red on the security list. Please come back and tell me, CTO, for example, what's it going to cost to get to yellow? What's it going to cost to get to green? So the CEO can keep it in terms she understands of finance, trade-offs, budgets, etc., while still enabling the technologist to have the deeper conversation.
Interesting. So are you finding that your core users are non-technical, or do the development groups also embrace the tool? Who's the primary user? Is it the non-technical user that can come in and ask questions of what they're seeing? And are they driving that interaction?
The four primary users of the Sema Code Scans product are boards of directors, CEOs, heads of mergers and acquisitions or corporate development, and CTOs. CTOs can be explaining the results if it's a scan performed on their code base, or they might be understanding the results of someone else's. It is that C-suite and board discussion about the health of the code base. It's an interaction between those four groups and a fifth. Most of Sema's work happens through consultancy, so technologist advisors. That's a critical fifth group who uses these results. But not, hearing that list, not on the primary set are developers and development managers that sometimes look at the detail, but the primary audiences for the core report are those five, C-suite type roles.
So basically people doing diligence.
People doing diligence, reading board decks, understanding what's it going to take for the company to make it, for the software organization to take it to the next level. Executives thinking about the health of the business more so for this product than coders doing the software engineering themselves.
And do you find that one of the things with a lot of these tools is coming at it from the development tool base, which can be even more kind of geeky and nerdy, is that they spew a lot of light and obvious things that don't really matter in the large context, but usually buried underneath a lot of this straightforward, let's call it, stuff to deal with, are actual issues that are meaty that can take down servers and cause real problems. And it requires sort of a fair amount of contextualization to understand what it is you're actually looking at. Do you find that performing that contextualization task for non-technical audiences is a challenge? And what kinds of stuff do you do to help them understand the practical ramifications of what they're looking at?
I definitely accept the premise of this question. I wrote about this a few years ago. I think it's probably the best thing I've written, at least the most important thing. Code is a craft. It's not a competition. Everyone can win. It benefits from people working at it and improving what they do. It is innately satisfying. Not that it doesn't also come with external benefits, but doing it the right way is itself satisfying. And it's not about winners and losers. And so much of helping software development work right in enterprises who are competitive and do have numbers to hit is respecting the craft of coding while also being realistic that, my view, it's absolutely incredible that millions of people get to carry out this really wonderful job of building and ideating and testing. Being a software engineer in the right place can be a magical job. In exchange, we have to make sure it makes sense for it's helping achieve business goals or organizational goals. And so that's something we're really excited about. And we think the right kinds of communication can go a long way. To be a slightly more specific, we try pretty hard in our, so this is a report in the CodeScans product, for example, but also in our dashboards to provide that contextualization from the beginning. Maybe I'll give a tiny example. We have a 1 to 100 score about code base health. That is provocative and opinionated. We did a lot of analysis, probably 5 years of analysis to collect enough data before we could create a scoring system like that. Because it's not hard mathematically to start assigning rankings. What's hard is to do it with judgment and integrity. And just to give two tiny examples of how that methodology works, which is public, happy to tell anybody who it is, it's not a secret. Of that 100-point scale, and this is non-functional requirements, or what we call code base health, not what the product does and how well it does it, but things like security and quality and open source risk, et cetera. Of those 100 points, approximately 1 point, it is 5 divided by 4. So 1.25 points is how many line level warnings the code base has. Audiences, a technical audience listening to this, that's linter results. Folks who are not technical, that's like Grammarly findings, summing up all the Grammarly findings. We still do that segmentation of, are you in the top quartile or the bottom quartile, wherever, of how many of those line level warnings you have. But even if you were extremely off the charts in either direction, it's really not going to move the needle on the health of the code base and the ability to maintain and expand it. By contrast, we have one individual metric that's worth 25 out of the 100 points. Do you like improv? Do you want to take a guess at what we think is the most important metric about code base health? And I can give you a clue if you want it, or no clue.
Is it just the code base you're looking at, or are you looking at the GitHub repo interactions too?
Great question. So it is not just the lines of code. That's why we call it the code base. So this is something that's not specific to the lines of code. That's the clue.
I imagine maybe like the rate of reviews on code or something.
That is amazing. I'm a passionate fan in code reviews, and so I would definitely agree that one's very important. The one that is most important for us, 25 out of the 100 points, is key developer retention, which is to say product group by product group, what percentage of the developers who wrote a meaningful portion of that code
are still
at the organization.
Oh, not necessarily on the team.
Not necessarily on the team. So if you wrote the most code on product A.
Oh, that's funny. Yes, because the core developer writes the thing, disappears, and then other folks don't want to get their hands dirty and like dance around the code, around the periphery, and then they find a way to interact with the barnacles and make them bigger. and
exactly right.
It just grows into it.
Exactly.
That makes sense.
But it makes sense, right? And the cute way of saying it is that having the code, but not having the coders who understand it, is like having a half-written novel without the novelist. Because code doesn't end. Of course, you have to upgrade it, you have to patch it, you have to be responsive to versions changing, et cetera, et cetera. So the code itself, without folks who have that deep subject matter expertise, is incredibly risky. And by contrast, having coders who know the code makes a huge difference.
So what did you do to make it, like, how did you determine that should be 25% of your score?
Yeah, we did this for 5 years, and we had conversation after conversation. So first 3 parts response to your answer, which I'm taking at length. One is I totally agree, code, the context really matters, really, really matters in a way that's true for code. I think arguably more than any other modern corporate function, certainly one of the most. Second, we did a lot of research. I had a lot of data to apply context automatically out of the box, so to speak. Things like saying 25x developer retention counts 25x more than line level warnings. The third is, even with our report, you still need that contextualization. You still need the conversations to really get at the ground truth. The quick example, we were looking at a code base that in the summer of 2020, where the development activity decreased by about 20%. And it was a big enough company. I mean, if you have 2 developers and it declines 2%, someone could go on vacation or whatever, right? There's lots of possible reasons. But a company this big, 20% was meaningful, and it wasn't just random variation. And when we asked, well, what was actually causing, it looks like there was a 20% decline. Is that right? There could be a false positive, blah, blah, blah. And the answer was there was a 20% decline in development activity. I said summer 2020, the company was facing some pretty significant economic risk because of COVID. And they furloughed the engineering team or everyone at the company 1 day a week. People just didn't work on Fridays for the 6 months leading. It's usually not that it's usually not that pretty, but in all cases, even as hard as we try to get the context automatically applied, it's still definitely necessary for an expert to understand the code and go deeper. And that's why Sema is a software company. That's why we work with advisory partners, because it's their job and expertise to get that context, to hear the real story and understand it.
Perhaps you're not sure whether AI can really transform your business. Maybe you don't know what it means to inject AI into your organization. Maybe you need some help actually building models. Check us out at xionyx.com. That's XYONIX.com. Maybe we can help.
So let's talk a little bit about the AI role here. So before we dig into maybe what I'm assuming is like the use of LLMs to kind of assess code quality, can you walk us through what is the objective criterion for saying that X block of code deserves a score of 100 versus a score of 1 or 78? And like, what's the difference between your scoring? So like, is this heuristics that you have evolved, or is there something directly tied to maybe productivity on a code base over time? Or like, how is it that you're defining the objective truth of the score?
Yeah. And I don't know that I would say objective. I'd say opinionated, based on evidence, and transparent. So folks can see our methods, and if they think they would like to weight it differently, they are able to unpack the results, unpack the components, and apply their own weighting in rubric. We worked pretty hard to get it right, but there are so many experts in software development and understanding and assessing software engineering. We welcome folks bringing their own point of view. So there's certainly not just one way. It just happens to be our way that seems to work pretty well. When we talk about that 1 to 100 score, it is at the level of an organization, could be one or more products, all of the software engineers involved, and it encompasses now 8 different areas. One of them is open source legal risk. A second is code security. A third is code quality. Like any proud parent, I would be happy to name all 8, but it gives you the idea of those.
So if you can go into those, I think knowing the buckets that you're looking at is helpful, and then understanding their temporal relationships also helpful.
Give me an example of explain the temporal relationship.
Like, are you going back 10 years into time in a GitHub repo and looking at the code's evolution as a function of its security score changes over time, something like that?
Perfect. So the 8 are code quality, various forms of technical debt. That time series is only the present. Okay. Second is development process. That is how the code, the development activity on the code over how it's evolved. We do time series of all time, but the particularly interesting time period is the last 6 months. So we might see how it's changed, over years or decades. But really, with respect to risk and consistency and the future, it's really heavily weighted towards the last 6 months.
So some of those variables would be like frequency of check-in, lines of check-in of developers.
The degree to which comments are being added and how robust those comments are. Mm-hmm. Degree to which testing is being added. So we call that a process metric, whereas the absolute amount of testing is part of code quality, but adding testing is part of a process metric.
And what about are you looking at stuff like AI generative code insertions? So somebody's using GPT or Claude or Copilot or whatever, and they're taking suggestions and inserting, code from that versus what you can guess to be handwritten code.
Yeah, and so that is one of the 8 modules, and it really is our second product. For the first 6 or so years, we only did the other modules. One of them is open source risk. As your listeners know, of course, open source is code the team didn't write, came from the community. It's a good idea, avoids rework, etc. Helps with developer satisfaction, but it comes with legal risk. It comes with security risk. It comes with maintainability risk. All those things are also true about GenAI code, whether it comes from a GenAI specific, a code specific GenAI tool or a general one. It's a good idea for team productivity. There's literally a new study on GitHub that just came out today, not by GitHub, that's really quite positive. It's good for developers if used correctly and there's the right scaffolding and fits into their workflow. But it also comes with security risk, maintainability risk, IP risk, to a certain extent, all of those. And so actually some of our customers said, you detect open source composition and analyze its risks. Please do the same for GenAI code. And so that became both a module of the report and also a standalone product. So our contribution and thought about GenAI is detecting and helping guide the use of GenAI code, which we do in part through a GenAI model. So Deep, you're exactly right. That is now one of the 8 modules that we use.
I had an experience, maybe this is a while ago, but I was selling my company, and at one point I was sitting in a room with 7 lawyers. As a non-lawyer, it was a horrifically boring conversation to be in. But I was the only one who actually understood how the system worked. And there were 7 lawyers, and they were all arguing for what I think was almost 2.5 hours on whether any software at all could be used using the Sun Java language. At some point, I had totally tuned out, but I was just like, I was doing the math in my head. I was like, okay, this is like, at that time is like, $400 to $600 an hour per lawyer times 7. And I'm just calculating the loss in the sale of the company that's going to these people who are arguing about something that I can only assume is like the most idiotic discussion that I'd ever heard in my life. So I spoke up and I said, look, I don't really care about the legal nuance of this argument right now. All I can tell you is there's 22 million developers that are using Java right now. So other lawyers who understand this in a lot more depth have already blessed it. So I think it's time to move on. And then they basically just sort of stopped and said, okay, yeah, let's move on. I bring this up because it seems like if you ask a bunch of lawyers to look at the risk of something like GenAI introduced code, they're depending on the evolution of the new technology, they're going to take a very conservative stance in the beginning phases, a slightly less conservative stance 25 years later. But in general, it's going to be an extremely conservative stance because they're lawyers. But there's a risk on the other side of saying, hey, we're going to be the only dev shop that doesn't use GenAI. Again, I keep going back to this contextualizing the findings. But to me, this is the challenge with what you're trying to do here, is getting non-technical audiences to understand what this stuff means. Stopping teams from using generative AI is something that many, many large companies have decided to do, and will only kind of get dragged in over time as they start acquiring startups that ignore all of that advice and do it anyway. And the milieu of legal actions that will erupt will eventually settle into something like, I don't know, just do it, like whatever. That's where it's going to wind up, because it's too much of it's impossible to really detect whether or not something is GenAI written. If you're doing it successfully today, it's only because developers haven't figured out you're doing it and it's getting in their way. But the second they do, there will be a long army of tools to obfuscate it so your models will fail again. So what say you to that critique?
Amazing.
Because at the end of the day, this is actually not possible, is my argument.
That detection is not possible?
That plagiarism detection that's accurate is not really possible.
Do you think open source code detection is possible?
I think it's possible to detect when somebody puts a library in or somebody attributes the code effectively. But I think it's not possible to detect when somebody jumps into an open source Apache project, for example, or GNU, let's take a GPL project, for example, cuts a bunch of code, pastes it into their IDE, relabels a bunch of variables, starts manipulating it, like exerting some editorial control, and now shoves it into their code base. So like somewhere there exists a spectrum. On one end, it's like, yeah, proper attribution. On the other end of the spectrum, it's like, I expended effort to obfuscate the fact that I stole this code. And I think the same kind of spectrum exists in the Gen AI world. Hey, I've watermarked my Gen code generation, and I've got like the statistical distributions of, variable naming techniques and all that kind of stuff. You can catch that. But can you catch the other end of the spectrum? No. That's why I think it's so important to like contextualize this stuff.
Love it. Many, many, many points to react to on what you've said. I'll start at the biggest picture and then get into detail. First, we detect GenAI primarily to increase its usage and to increase its responsible usage. In almost every situation where we looked at code bases, code owners want to use GenAI and just want to make sure it's used correctly. And in almost all of those cases, that means they need to be increasing the amount of usage, not trying to prevent it. There are certainly some number of organizations who are worried enough about the risks involved that they're not quite ready to adopt it, but those are few and far between. The vast number of professional developers are using GenAI coding tools at work, and we are incredibly supportive of that. Tools like ours are there to, frankly, to increase usage, assuming it's that's the organizational policy. So it's helping give guidance on how much more it could be used in what parts of the code, and then also to make sure that the code is used, that GenAI code is used safely. And I can go through the detail, but the bottom line of using GenAI code safely is making sure that a human is reviewing the code and putting their stamp on it. And almost always that means the code coming out of the LLM is going to get modified, or we say blended, by a coder. Extreme other example, if you were looking at a code base that was 100% pure GenAI, i.e., the only thing that happened was someone prompted an LLM and spit it out and didn't make any changes to it, you should be very concerned that there might be security issues, there might be quality issues, there might be IP risk issues, etc. So for us and for our users, GenAI code transparency is generally about increasing the amount of GenAI code, number one, and then number two, making sure that it is blended GenAI code rather than pure. Does that make sense?
Yeah, that makes sense. So tell me a little bit about like what's the general state of copyright concern? Because what I'm reading from you is that that's a fairly liberal take on Gen AI generated code. So is the copyright concerns of whatever OpenAI or Anthropic or whoever did to like slurp up code, and it's just sort of accepted that it's okay to like use this stuff? Because the parallel in the natural language generation world is that it's not okay. High school teachers certainly will be bothered at the idea that their kids just said, write me an essay about X, and then maybe a little bit further up said, hey, write me a paragraph on X. What's the reality of the copyright concerns around generated code?
Yeah, I'm going to give a little bit of structure before I answer that specific question. Of the possible risks of Gen AI as opposed to the benefits of increasing productivity, one risk is it comes with security vulnerabilities. Another is there are code quality risks, such as lacking context, such as not being understandable, such as making up packages. And then there's intellectual property risk. Within intellectual property risk, there's copyright or training set data infringement. Let's just call it training set data infringement, which could include copyright infringement. There's receiving copyright on the code for companies that pursue copyright protection of software they've written. There's patent protection on the code they've written. There's trade secret protection. And then there is something that we call deal risk, a variety of intellectual property risk. With me so far?
Yeah, I am. Yeah.
You're thinking something.
I'm thinking of a very specific scenario, right? Like,
go ahead.
So I'm not using a coding tool. I'm just going to ChatGPT or Claude or something, or Gemini.
Yeah, a general LLM.
I'm going to a general LLM, and I have no idea what they trained on because they're not public about it. So I don't know whether or not, for example, ChatGPT trained on GPL code, for example. And when it generates code, I have no ability to prove that it did not use GPL code in its understanding and its generation. Am I like potentially infringing?
Okay, so we'll call that training set data infringement risk.
Okay.
We assess it is very unlikely that there is actual copyright infringement of the training set data because the LLMs weren't trained on copyrighted code. They were trained, some of them, on open source code. And so the infringement is less about copyright potential risk, we assess the risk from copyright infringement to be extremely low. But now let's talk about license infringement. And so the specific method that this could matter, just as you said it exactly right, a LLM used for their training set open source code, and some of that open source code came with a restrictive license, such as a copyleft, a GPL or AGPL, and that code makes it into your code base. So that's the topic. Couple caveats. What we're about to say is not legal advice. And if you are working on, if you are at a company large enough to be worried about this, then you absolutely should be bringing in your own lawyers and have them opine, because they're the ones who are going to need to back you up. That's part one. Part two, an extremely important thing to do, no questions asked, is to only use LLMs from specific companies with a tier that provide indemnification against this risk. So several organizations have already thought about this and are providing indemnification clauses if you buy the right license tier that, to the best of our knowledge, they have not been tested, nonetheless are aimed at this scenario, a training set creator coming after an LLM user. Now, if you're at an LLM, of course, training set creators are coming after you. That is a known and real risk. These companies are being sued as we speak. When it comes to LLM users using a tier of an LLM with the right kinds of indemnifications and protections, and by the way, some of those tools you can choose not to be trained on certain open source libraries that are riskier. We would certainly recommend that as well. We assess the open source infringement risk to be relatively low, but again, we would most certainly want you to check with your lawyers to make sure that the company as a whole, it feels comfortable with its risk exposure.
So that part of it. I want to just translate that a little bit. So if I'm using Microsoft Copilot, for example, Microsoft puts an indemnification clause like this in their license?
At least at enterprise.
If you're paying some bucks, you get
not the free. Not the free version, but the enterprise version.
And therefore, whatever, if somebody sues me or if I'm going under diligence, I can just say, like, hey, all this code was written using Microsoft Copilot or whatever, at least to my knowledge. Now, on the other end of the spectrum, if my developers are just jumping into ChatGPT and like cutting and pasting stuff out, I don't know if they have an indemnification clause like this. I'm guessing not, but
they do as well at the right tier. But absolutely, anybody out there who's saying we shouldn't let our developers use it, I'd say, well, they are using it. So please give them the right tool with the right license so you're protecting yourself, not only from training set infringement, but also trade secret.
Yeah, that's like a really intriguing point, because that was what I was going to get at, is like, if developers are going to use this stuff no matter what, they're going to take the path of least resistance and they're going to do it. So I don't think this message is out there very loudly spoken, the one that you're kind of making here right now, which is developers, unless they're living in a rock, are going to use tools. You're best off giving them tools that contain indemnification. Otherwise, you're assuming that liability risk.
For indemnification and also for trade secret, which basically means you get to protect your IP as long as you don't give it away and put it out on the street. And just like you shouldn't upload your code to Stack Overflow or publish private code on open source repos, so too, you should not use a entry-level license on an LLM and load your code into it, because then it becomes part of their training set. And so the more professional licenses of the major providers, that license comes with an agreement not to train on your data, as well as indemnification. So we are advocates of GenAI for coding primarily because it helps developers and therefore helps organizations achieve greater things. But my goodness, if you're on the fence, know that your developers are going to be finding a way anyway. Like, imagine trying to prevent open source usage. Imagine it. It would be impossible. It would be crazy, because developers are good at finding solutions.
Oh yeah, they're going to tunnel out if they have to. They're going to
tunnel out.
Working it from home. And I would kind of go a step further, which is, I would say that even if you do give them the tools, they're picky lot. They use the tools they want to use. They'll tell you they're using your tools, but they're not going to necessarily. And they're still going to jump into, OpenAI or whatever they want and generate their code and stick it in your code base anyway. So I'm assuming there's some risk exposure that's reflected in your scoring, maybe based on this kind of stuff too.
Yes, I second what you said. Worst is not letting them use, quote, not letting them use any tools at all. That's not good. Forcing them to use one is certainly better than not letting them use any. Where it is feasible, let the developers pick the suite of tools, within guidelines. It has indemnification and there's no retraining. Let them pick. And ideally, if an organization has the budget, let them use more than one because the technology is evolving, because individual developers have different preferences. There's anecdotal evidence that certain of these tools are better for certain instances. For most organizations, the monthly cost of a license for a coder to use a GenAI tool, whether it's specific to coding or not, is many, many, many orders of magnitude less than the cost of that developer. So if they think that one or two or three tools combined will help them do their job better, almost always the ROI pays for itself. Sema has a free ROI tool if you want some help doing that math, but orders of magnitude, buying several $20 to $40 licenses per month per developer, given what many developers make some basic conservative assumptions about the impact on their productivity, job satisfaction, retention, all the above. There's usually a 10x return, 1,000% ROI.
Interesting.
Need help building a great chatbot, or perhaps help with computer vision, natural language processing, automated content creation, conversational understanding, time series forecasting, customer behavior analytics. Reach out to us at xionyx.com. That's XYONIX.com. Maybe we can help.
Okay, let's maybe change directions a little bit. I want to spend a little bit of time. I'm going to sort of guess how your system works, and I want you to tell me where I'm wrong. I haven't actually spent much time with it, but I'm guessing that you pointed at your GitHub repo or some other repo. The system has privileges to go in and look at not just the current source, but the historical rendering of the source. Then you churn away maybe on a per release basis, maybe on a per day basis. You probably use a lot of available tools that have been around for a bit that will grab the code and look at warning levels at the line level, like you mentioned, stuff like linter and javadoc and all that kind of stuff. Then you probably take all of that information plus the actual code, plus maybe something else that I have to think about. But then you go to the LLM and you ask for scoring with explanation on why it's scoring. Maybe you have fine-tuned models there to fine-tune the scores based on a ground truth, if you will, where you sort of manually went through and rated different blocks and chunks of code. And then you wind up with your scores, something like that. Am I off on Mars, or am I in the ballpark, or?
Very good. Let's just take the code scans product, producing an end result analysis, an end result report about a code base. You're absolutely right. A big chunk of it is mechanical or deterministic evaluations of the code for things like line level warnings or security warnings, etc. Broadly speaking, wherever we can be mechanical, we prefer to. We don't use AI for its own sake. One, because we don't use any tools for its own sake. It's all about outcomes, but also a big portion of what we do in code assessments is for incredibly high stakes situations. And it is way easier for everybody involved, including folks who've had blood, sweat, and tears careers trying to get this code base to a good enough spot to sell it. It's so much easier to have a conversation with mechanicalistic output, deterministic output. We counted 75 warnings, security warnings. Companies of your size and stage typically have 300 to 800, so you're doing better than average, right? Or vice versa. So the rest of the product is primarily deterministic, excuse me. For AI detection in these reports, we do use a probabilistic AI approach. We have our own tuned deep learning model that was indeed trained on definitely GenAI code and definitely not GenAI code. How did we do that? Definitely not GenAI code. We used pre-open source code that came before GenAI tools. Coding tools were out in the wild. Definitely GenAI code. How do we know that? We synthesized it. We gave NLM instructions and spit it out. And then it produces a prediction score of whether or not it's GenAI or not. And then we carefully manage the cut point to manage false positives and false negatives. And then there's just been a ton of real world experience. Code is so varied that you just need lots and lots of bats to make any interesting comment about code because of the number of languages, the number of uses, etc. And so the work after the original tuning of the model has been hundreds of tweaks based on new data, based on false positives and false negatives, constantly tuning the model itself and then optimizing the surrounding tooling to get the right balance and as low as possible false positives and false negatives.
I think that gets me in the headspace of what you're up to, and I think I can kind of wrap my head around it. So we've talked about what you do. We've talked about how you do it. Let's talk about the should. Like, this seems pretty straightforward. Like, you got a code base, you want to go in and like assess if you've got dangerous code, but like, let's get imaginative here. And a lot of times it might not have anything to do with Sema. Like, it might be up a level or two, but what are some of the ethical scenarios that might come up here? Maybe we even have to go out 5 or 10 years, but like, what are the ethical scenarios here that, maybe, or the ethical questions that maybe you struggle with?
Sure. I should say that I've been incredibly lucky from where I grew up and the education I've had and the parents I've had and the career opportunities that I try pretty hard to only work on things that are either morally neutral or morally positive. Doesn't mean I always get it right, but we certainly try. I try pretty hard to have made those choices and building this business with that in mind. The number one ethical issue about GenAI code is making sure that humans are still involved. And we come back to this notion of pure versus blended. I do not foresee a time where a human supervision of what that code is up to is no longer necessary, certainly not for high stakes software applications. And so for us, GenAI code transparency, not just GenAI originated, but how much of it is pure versus blended, is, we hope, an extremely important tool to make sure that developers continue to stay to touching the code because of what could go wrong with code going in the wrong direction. We also think it happens to have some positive benefits for coders. The rise of open source code didn't eliminate the need for coders. It changed the job, which is a big portion of the job is deciding which package to use and being thoughtful about making those trade-offs. You're a system designer more than, heaven forbid, building your own front-end libraries, right? Some people can do that, bless them, but for the vast majority of people, they can stand on the shoulders of others. We think GenAI should and could be the same way, which is it can avoid some of the manual work. I mean, there's no substitute to learning how to code by doing it by hand and understanding the basics. But once you get the judgment and wisdom, you can go faster with tools, just like open source with GenAI. But we really want developers to stay involved for the code base's sake.
Do you think that we run the risk of turning your average developer into a Homer Simpson who's just keeping an eye on the nuclear plant? I mean, nuclear plants, they're designed to run for centuries and maybe even millennia without human intervention. When you have to write your own code, your brain's pretty actively engaged and it's fun and interesting and quite engaging. When you're hitting a button and code comes out and it fails 1 out of 7 times, you're still fairly engaged. And I'd say maybe 1 out of 3 times, we're at that sort of point for at least coding in the small, like an encapsulated function, something that's like a really kind of a narrow task. The rate at which this stuff is getting better, it's an obvious next step to like have a higher stack reasoning model say what you would say when you look at this code. 5 years down the road, it's hard for me to imagine where the models aren't almost always right. So then it's inevitable that you start jumping up a level in abstraction. Very, very few of us still write anything in assembly. Similarly, like if you go back with each era, few of us write much in C even anymore today, and less so in C++, and even less so in higher stack languages like C# and Java. What's the trajectory here? Like it feels to me like it's a concern in general with AI that we dumbify the people that have to use the stuff. You no longer need this really exacting thinking, and the assist is getting so much better. At some point, you're like, not Dilbert, but like the dumb boss, the pointy-haired boss surrounded by incredibly capable people. You think you know what's going on, but you don't.
I definitely understand that concern, and I definitely think it is worth keeping track of. And of course, the honest answer is I don't know for sure the direction we're heading. A couple observations. I accept the premise that, over the history of coding, the work is getting more and more abstracted. Folks need to know the details a little bit less relative to previous generations. I think that is a fair encapsulation. Of course, my observation, I'm sure it's yours as well, that the current generation still has many, 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 many opportunities to really understand the code, and needs for coders to understand the code and go in deep. That just because folks aren't inserting the punch cards like my parents did when they learned to code, right? There still are today great opportunities to stretch your brain and to have to be interactive with it to understand it. That's been true at every stage of software development. It's certainly possible that we will get out of that completely, but the history is, so far at least, is on our side, that there will at least be, for some developers, the need to really understand. I do think the rapid advancements of these Gen AI tools will change the nature of folks' jobs. I think there's no question.
Already has.
Already has.
Tremendously,
Yeah.
tremendously. Even
And
in just the last couple months, it's changed so much over a year ago.
exactly. I'm still at the point where, we see it as a change in degree, not yet in kind. There have been low code platforms where a very small percentage of people have to learn how to have to code the low code programs, and then a vast number of people can take advantage of it. You could argue that learning Excel, right, a small number of people relative on Earth program Excel, and then hundreds of millions of people use Excel itself. They're certainly not Excel programmers. There still is some thought and effort involved, obviously a lot of thought and effort involved, but it's not traditional programming. I do think we'll continue heading in that direction. I think certainly more and more people who aren't traditional coders will be able to create code as a result. We're obviously seeing that right now in at least in toy examples. That's only going to continue. I guess I'm an optimist that there will still be hard problems that humans need to design, need to interact with the components to make it work. And I honestly, this is not puffery. I don't believe there is a meaningful difference between putting Gen AI coding tools to work and open source to work. I do not. They're both code you didn't write. It takes an incredible amount of judgment to decide how to use it and whether it's right, and be situationally appropriate and stitch it together with the context that you need to solve the problem. I really do believe that Gen AI coding assistants, whether or not they're Gen AI specific or general, I really believe that they are just an extension of what's happened with open source.
Yeah, I'm going to riff on that a little bit. I think probably the thing about open source that helped it really take off is that you can take your library and you can stick it in your application and just use it and never crack it open and look at the source. But generally, if you do so, you have trust in somebody who has opened it up and looked at the source. But the point is that with all open source, by definition, you can open it up and look at the source. And that source is human intelligible by people who are skilled in the art, and they can go in and figure out what it's doing and how it works. Now, today, we're talking about generation of computer languages that programmers understand and know well. Tomorrow, I think we have a choice. I think we'll probably, with the increasing power of these models, go up in a layer of abstraction and just talk to them in English, or whatever language, and interact with them in some kind of like hybrid, super high level language. The ethical question I would raise is, do we have a right to dig in down to the low level of the code that gets generated from that high level interaction? Today, we take it for granted. Everybody, you go to GPT, you say, make me an algorithm that does blah, it spits out code you definitely understand, you put it in your IDE, you go. Tomorrow, I'm less convinced that we're going to even want that step in there, that we're just like, even speaking for myself, I was working with a vector store, this tool, OpenSearch, and I didn't want to go out to Stack Overflow like I would have a couple of years ago to like get my toy example together. I just need to take this thing, make an index, stick a document in, stick 5 documents in, grab a toy document, search for it, give me the output. So I go to 4.0, I say, do this, it spits out something, I run it, it fails. Yeah, I can go look at the code, but it takes like time and energy, and I'm lazy and I got to go to lunch in 20 minutes. So I just copy paste the stack trace, stick it back in 4.0 and say, try again. I loop around 6 or 7 times. It keeps flailing. And then I'm like, all right, whatever. Let's just use O1 preview. I do that once. It works. So now I can go look at the code. But fast forward not even a couple of months, right? Like O1 churned on it for a good couple of minutes because there was something going on in there that was significant. Fast forward a couple of months, it's going to get faster. That's going to get more seamless. It's going to get it right. It was a fairly complicated little piece of code. It wasn't super complicated, but I'm lazy and I didn't bother. Now, fast forward a couple of years, I don't think I ever even need to crack it open and look at the code, but whether or not it's even possible for me to crack it open and look at the code is an open question for humanity. And I feel like that is something that we should mandate maybe by law or something. But it's like if I take my Python, I guess I can, jump all the way down into the executed assembly, but it's certainly not convenient for me to do so. And it's not something that I have to do. But it feels to me like core to your premise is a future where humans actually can jump in and see what's going on. And the risk is, like the doomsayers are like, well, how do we know there aren't Easter eggs in this generated, that the AI decided to put it in there on its own? Okay, maybe it just screwed up and put them in there. But like either way, it's a legit concern.
I do believe that transparency about the use of GenAI is important today and will only increase. I'd say adoption is outpacing transparency requirements and concerns, and not just about GenAI for code, but GenAI in general, because people are experimenting with this new technology and finding applications for it. I used to say it was at least as important as open source and probably as big as electricity. I now say it's somewhere between electricity and steam engines in terms of how it will transform the world. I like the spirit of exploration, experimentation that starts with, let's figure out what we do with it. So let's actually use it. As an example, developers are finding their way to it. 97, 98% of developers are using some form of AI, at least on the side. What will come with it? It will be transparency requirements, risk management, risk reduction requirements. And it is good that it works that way, at least in the system. People shouldn't be experimenting with the nuclear arsenal, using GenAI on the nuclear arsenal, but commercial grade applications, I'm delighted. I'm absolutely delighted. I do think, just like I'm a broken record, just like open source started with people using open source, and then at some point people realized the security risk and the IP risk and the maintainability risk, and added transparency requirements that are now mandated in procurement, in diligences, in insurance. Like we'll see that coming with GenAI for code and otherwise. I think ultimately, as long as you get the transparency right and the various forms of regulation right, I think it will be a net positive. I guess I'll be slightly provocative. I don't think there's a necessity that folks can open up Microsoft Excel's code. I think 99.999% of interactions with Excel can be users of Excel by people who will never be allowed to see it. I have faith in regulatory and compliance organizations to make sure that Excel was set up the right way without requiring individual users the right to see it.
Yeah, I didn't mean to imply that. I meant that developers have a right to get into
developers.
Like Microsoft Excel developers have a right to go see what the heck's actually being executed.
And I would say I completely agree with you. I guess when that comes, we'll have to be ready for it. But human developers must be in the loop. Full stop. Cannot see a world where they can't access it. I can't see it. I completely agree with you. For risk, it is the right thing to do. It is the right thing for safety to make sure that developers involved will be able to see the underlying code.
Yeah, I think it's easy today to say that. I think it's going to be a lot harder to say it tomorrow. Like, I think when the delta between a human developer and a machine developer is super significant, meaning that the machine developer is a lot better in most scenarios, I think that time's coming. And when it does, it might not be the low friction, easy choice it is today. But anyway, thanks so much for coming on the show. I think this has been a really fun discussion. I think what you guys are doing it seems super practical and super, super helpful. And I think your orientation around tapping into what can be done and seeing how can we get developers more efficient, it seems like a natural next step for us. So thanks so much for coming on.
Deepu, was so fun. I really enjoyed the conversation. So thank you for making time for this.
That's all for this episode. I'm Dhillon, your host, saying check back soon for your next AI injection. In the meantime, if you need help injecting AI into your business or project, Reach out to us at xionyx.com, that's XYONIX.com. Whether it's text, audio, video, or other business data, we help all kinds of organizations like yours automatically find and operationalize transformative insights.